In this lecture we're going to start talking about probability distributions, and in specific we're going to talk about discrete probability distributions. Discrete probability distributions are like the integer frequency distributions that we saw in the first module. That's contrasted with the continuous probability distributions, which are analogous to the intervalled frequency distributions that we saw in the first module. So with a discrete probability distribution, we have a finite number of outcomes and with continuous we have an infinite number of outcomes. Alright, examples of both discrete would be like rolling a die, and so that you have 6 outcomes. Continuous example of that will be probability of getting a phone call during a certain period. From 10 to 11 a.m. Okay, it's continuous because we could talk about the phone call from 10 to 11 a.m. or from 10 till 10:01 or from 10 till 10 and 1 second. Alright, you have an infinite number of outcomes. You can divide time up infinitely and talk about as I said, an infinite number of outcomes. With rolling a die, we only have 6 outcomes, for instance, so that's finite. Alright, at first we're going to talk about our discrete probability distributions. And in probability distributions with discrete, quite often we will have x being a number. And let's just, since we've just talked about it, look at rolling a die, and so the probability of each of these outcomes for this particular case is a 6th. Alright, that's not always going to be the case that we have the probabilities of each being the same. Alright, but in this case we have the probability being a 6th. And so we can talk about the probability of getting a 1 or a 2 or a 3. Alright, so if we were talking about 1, 2 or 3, alright, so the probability of that is 6 plus 1 6 plus 1 6, 3 6 or a half, etc. Okay, now let's look at a sort of a better example. Alright, for instance, let's talk about x, which is called a random variable in this case. It's not a variable like in calculus. It's a variable here because it can have different values. It's random because its value is determined sort of randomly. Okay, not exactly randomly. So in this case, let's be x be the number of times the stock market rises in a week. It's a normal week of, say, 5 trading days. Right, so the x can have be either a 0, right? 0 rises, 1, 2, 3, 4, or 5, for instance. Okay, and let's just make up some probabilities. No rises, just 5%, 1 rise, 10%, 2 rises, 2 increases, 23, 30, 4 rises, 20 again, and 5 rises. It's 0.15, and if I've done everything correctly here, this should add up to 1. Alright, so the 0.15 and the 5 is 0.2, 0.2 and 1 is 0.3. Okay, that's 0.5, 0.8, 1. Okay, so the total probabilities, as we saw in the second module, must add up to 1. Alright, these are all the 0, 1, 2, 3, 4, 5 are mutually exclusive events, etc. Alright, and from that we could answer some really basic questions, but be alert with these, because a lot of students seem to have trouble with at least, more than, less than, greater than, okay, at most, all those sorts of things. Alright, so let's talk about the probability, just get our feet wet, of 2 increases. Alright, so that's just the probability that x is equal to 2, and we just read that from the chart. Alright, and so the answer is 0.2. Probability of at least 2 increases. It's the probability that x is greater than or equal to 2. At least 2 means 2, 3, 4, or 5. Alright, so we'd add up those probabilities, and that looks like, alright, it's 0.5, 0.7, 0.85. How about the probability of at most 2 increases? Right, at most 2 means x is less or equal to 2. Could be 0, 1, or 2. Those probabilities there we add up, right? So 15, and then the 35%, 0.35. Probability of between 1 and 4 increases, and just to be safe, I'll say that's inclusive. That means including 1 and 4, so this would be written as the probability of getting x greater than or equal to 1 and less or equal to 4. Okay, so those probabilities, and that's what, well, the easiest way to do it is to say, well, there's 5% here, 15% here, that's 20%, and so these must be the rest, so that's 80%. Okay. The probability of less than 4 increases. Alright, let's note that I don't have the equal sign on that inequality there. Alright, so that's the probability of x strictly less than 4. Alright, 4 is not included, so we would have 0 through 3. Alright, so let's scroll just down so slightly. Alright, and so that would be whatever, alright, 15, 35, 65, 0.65, well, 65%. Okay, and let's just, I guess, do one more. The probability of more than 2 increases. More than 2 means 3, 4, or 5. So we add those probabilities up. That's 50, 65. Alright, again, strictly greater than 2. And what did I say? That's 0.65 again. Okay. Alright, and hopefully you've understood all those distinctions. If not, be very careful and try to learn them. Alright, let's go to our next page and draw that distribution again. Alright, just so that you remember, this is a discrete probability distribution. Probabilities 0.05, 0.1, 0.2, 0.3, 0.2, and 0.15. And we're now going to talk about the mean and standard deviation. Of this probability distribution. Alright, the formula for the mean of the distribution, also called the average or expected value. Alright, so the expected value of x, or it's also listed as the Greek letter mu for the mean of the distribution, is calculated by going sigma x times probability of x, which is roughly analogous to your weighted probabilities, right? Sigma wx, where the w's now are the probabilities. Okay. Alright, and the standard deviation. Before we can get the standard deviation, we'll talk about the variance. V of x, or little sigma squared, is sigma x minus mu squared times p of x. Alright, this is sort of a complicated formula, which can also be done more simply as sigma x squared p of x minus the mean of the distribution squared.